Hello and welcome to another AQA GCSE 8300 series. This is the May 2017 past papers. This is paper 1H, which is the first paper in the higher tier. It's a non-calculator paper, so we're not allowed to use calculators, and we're picking up in question 23. It says, here is a velocity time graph of a motorbike for 25 seconds. Okay, so we've got the velocities getting faster and faster and faster and faster, then it slows down and gets slower and slower and slower and slower and slower. Okay. So after how many seconds was the acceleration 0? Okay, now in order for velocity to go up, it must be having a positive acceleration. And for the velocity to go down, it needs a negative acceleration. And the thing that is bang slap in the middle of positive and negative is 0. So negative acceleration, the velocity is staying exactly the same. So you've got a horizontal line. That's just a way of saying that the slope of a velocity time graph is 0 where the acceleration is 0. Or you could say the acceleration is the slope of the velocity time graph. And we want 0 acceleration, so we want a 0 slope. So we're looking at a point of maximum velocity because the velocity is constantly increasing, so the acceleration then becomes 0 when it stops increasing and starts decreasing. So we're looking for the fastest possible speed, which is somewhere around here. So let's zoom in and see if we can get a good look. Okay, so here the maximum speed is, well, that's 5, so there's 1, 2, 3, 4, 5. So if that's 25, then that's 26, 27. So 27, whatever the units are on the y-axis, would be the point where the acceleration is 0, is right here. You've got a straight line here. So it's this point here. So if we follow this point down, then we're looking at this position here. Okay, let's just zoom in a little bit more and get a really good look at what we're looking at here. Okay, so this is 5 and this is 10 seconds. So halfway between 5 and 10 seconds, well, there's a distance of 5 between 5 and 10, and half of 5 is 2.5. 2.5 plus 5, or 2.5 minus 10, is going to be 7.5. So this line here is 7.5. Okay, and this is halfway between 5 and 7.5. The distance between 5 and 7.5 is 2.5, and half of 2.5 is 1.25. 5 plus 1.25 is 6.25. And again, 1.25 minus 7.5 is 6.25. So the answer is 6.25 seconds. Or actually, probably be anywhere here between sort of 6 and 6.5 seconds. But anyway, let's say 6.25 seconds. And let's get a good view of what we're looking at. So the answer is 6. I'm going to put 6.25. And we don't need these. These are just a distraction. Okay, so 23b says work out the distance travelled in the last 15 seconds. Okay, well, just as the slope of the curve is of a velocity time curve is acceleration, so the area underneath a velocity time curve is the distance. and we want the distance travelled in the last 15 seconds. I know that the temptation is to misread the question and to go up to 15 and to try and calculate this area here, which we don't want to do. That's wrong. We're looking for the last 15 seconds, so we're taking 15 seconds away from 25 seconds, so that's 10 seconds. So we're looking at basically this area here. And they've very nicely given us a nice straight line here. So this is it's like a trapezium, isn't it? Okay, so if we draw a line here and a nice straight line, you can do a better job than this with a ruler, but I will try my best to do a straight line here. That looks to me like a straight line, almost. It's important that it is a straight line, so I read the graph correctly. Okay, I'd say that was a straight line. So now I've got a rectangle and a triangle, and I just need to calculate the area of these. So the height of this rectangle, the height here, let's zoom in and just have a closer look. Let's see if I can extend this line here. Oh, so this is I think every one of these little dots is 1, because that's 15, 1, 2, 3, 4, 5 makes 20. So this is, each one of these little squares is 1. So that's 15, 16, 17, 18. So I'm going to put this height here as 18. And I'm saying there's 4 here, because that's 22. So if this is 22 and this is 18, 19, 20, 21, 22, so there's 4, so this is 4 units. And of course we know that this is 15 units across. So the area of the rectangle is 18 times 15. And the area of the triangle is half of 4 times 15, which is 2 times 15. Okay, well that part's easy, I can do that in my head easily, that's just 30. Now 18 times 15, let's zoom out. Well, let's just write it out here, 18 times 15. Well, 5 times 8 is 40. 5 times 1 is 5, plus 4 is 9. And then, so this is 180. So that is going to be 270. So the area is 270 plus 30, which is 300 meters. And just double check our units. Meters per second times second is equal to meters, because the seconds cancel out. Okay, I hope you found that helpful. If you're taking your GCSEs this year, I'd like to wish you every success with your revision and every success with your exams, and I'll look forward to seeing you in another video.